Hello. In this class, we will solve a problem using Mollier chart. There are two boilers, boiler A and boiler B, discharge equal amount of steam into common steam pipe. So, let us have a simple diagram where we can easily visualize the thing. So, there are two boilers, one is boiler A and the other one is boiler B, and the discharge equal amount of steam into a common pipe. So, there is a common pipe here. So, let us say this is boiler A, this is boiler A, this is boiler B, and let us say this is common pipe, common steam pipe, and let us call this as C. Okay. Now, so they both are delivering steam to this common pipe, and from here it may be going to a turbine. Okay. Now, the steam being supplied by boiler A is 20 bar. So, the pressure here is 20 bar and the temperature is 350 degree Celsius. The steam from boiler B is at same pressure. So, here also the pressure is 20 bar with a, but it is wet with dryness fraction 0.92. So, X is equal to 0.92. Determine equilibrium condition after mixing. So, he is asking you what will be the condition of steam here. So, first of all, this should be solved by using energy balance. Energy balance. It is something like the energy coming from A, which is mass of steam coming from A, multiplied by enthalpy plus mass of steam coming from B and enthalpy of B should be equal to mass coming from, the total mass C and Hc. Whatever he is asking here, the final condition of the steam, he is referring to enthalpy of this steam at this place. So, we must know that Ma plus Mb must be equal to Mc because simple mass balance. Correct? So, they both are delivering equal amount of steam. So, we can assume Ma is equal to 1, Mb is equal to 1, then Mc will be equal to 2. So, Mc will be equal to twice that of this. Alright. Even if you assume 10 and 10, it will be 20. So, anyhow, whatever we assume, the equation is going to be same. Assuming Ma and Mb is equal to 1 kg. Therefore, Mc will be equal to 2 kg. So, it will be simply 1 into Ha plus 1 into Hb must be equal to 2 times of Hc. Or simply you can write Ha plus Hb will be equal to 2 times of Hc. So, this is our equation. If we know the value of Ha and Hb, we will be able to find out the value of Hc. So, how do you find out the value of Ha and Hb is the next question. Now, at 20 bar and 350 degrees Celsius, we know how to use data handbook. So, let us go to data handbook. For 20 bar, if the temperature is 350, what will be the condition of steam? So, I have a table A1 which is pressure based. For 20 bar, we can see for 20 bar, the T saturation is 212.37. So, 212.37. So, we can write for 20 bar, the boiling temperature is 212.37 degrees Celsius, which is T saturation. But at boiler A, temperature is greater than T saturation. Therefore, steam is superheated. And we know if the steam is superheated, we must see table, that is superheated table. In the BT Nijaguna data handbook, this is table A3. So, I will go back to table A3. So, I have a table which is copied. For 20 bar, I see for 20 bar you have listed volume, enthalpy and entropy. There may be different books which is organized in different ways, but the total idea is pretty simple. Here also he has mentioned for 20 bar, the saturation temperature is 212.4. For 20 bar, the temperatures are here. So there is no enthalpy values below that temperature. You see, below 212, there is nothing here. That is why only when it is greater than 212.4, you will have these values, right? So 20 bar and 350 degrees Celsius, is that correct? 20 bar and 350 degrees Celsius. So for 20 bar, 350 is here. So for 20 bar, we need the H value. 20 bar enthalpy is 3138.6. 20 bar 350, 3138.6. 3138.6 kilojoule per kg. So at 20 bar and 350 degrees Celsius, the value of H, which is HA here, is this much. And let us go to find out the value of HB. Now you know that whenever we talk about wet steam, the dryness fraction, so we are talking within the vapor dome, and we know that X is equal to 0.92 lies somewhere here. So whenever we have a steam which is wet steam, we know the equation has to be HF plus X HFG. Now HF is at same pressure, which is 20 bar. HFG also should be noted down at 20 bar. Now this is pressure based table, saturation table, right? Pressure based saturation table, because we are talking within the vapor dome, saturation table. So in BT Nijaguna data handbook, this is in table A1. So I will go to 20 bar. So for 20 bar, I can note down HF and HFG. So for 20 bar, HF is 908.6, 908.6 kilojoule per kg. The unit is written at the top, kilojoule per kg, and HFG is right beside it, 1888.7. 1888.7 kilojoule per kg. Now we can determine the value of HB is equal to HF, that is we are writing equation 2, 908.6 plus the value of X is given for the boiler B, 0.92 multiplied by 1888.7. So which is 908.6 plus 0.92 multiplied by 1888.7. So we will have 2646.2. 2646.2 kilojoule per kg. Now we have got the value of HB and HA. I will go back to the equation 1. See, equation 1 is HA plus HB is equal to 2HC. So HA plus HB is equal to 2HC, which is 3138.6 from equation 1 we are writing. From equation 1, HA plus HB 2646.2 must be equal to 2 times of HC. So this will be HC is equal to 3138.6 plus 2646.2 divided by 2. 3138.6 plus 2646.2 divided by 2. So that will be 2892.4. So 2892.4 kilojoule per kg. Now this is the condition after steam is mixed. I mean the steam coming from one is superheated and one is within the vapor dome, which is wet steam, and the condition of the steam after mixing will be enthalpy at C, which is 2892.4. For a detailed course on mastering steam table and molar diagram or pure substance is available in Udemy. Please follow the description link. Thank you.